Hello everyone, I am Nihal Mishra and today's our topic is biocatalysis. What is biocatalyst or enzymes? Enzymes are biocatalysts, the catalyst of life. Catalyst is defined as substance that increase the velocity or rate of chemical reaction without itself undergoing any change in overall process. Introduction: biocatalysis is use of natural catalysts such as protein, enzyme to perform chemical transformation or reaction of organic compound. The most obvious use of biocatalysis has been in the food and the drink industry, where the production of wine, beer, cheese, etc. is depend on the microorganism. Catalysis is classified as homogeneous catalysis and heterogeneous catalysis. Homogeneous catalysis is that catalysis in which the catalyst and reactant are in the same physical state. For example, if catalyst is solid state, the reactant is also in the solid state. Heterogeneous catalysis is that catalysis in which the reactant and the catalyst is in the different physical state. If catalyst is in the gaseous state, the reactant must in the solid or the liquid state. Classification of biocatalyst. The biocatalyst have 6 classes such as oxidoreductase, transferase, hydrolase, lyase, isomerase, ligase. Oxidoreductase, enzyme involved in oxidation reaction. Example: alcohol dehydrogenase and cytochrome oxidase. Transferase, enzyme that catalyze transfer of functional group. Example: hexokinase. Hydrolase, the enzyme which brings about the hydrolysis of compound. Example: lipase. Lyase, enzyme specialized in addition or removal of water, ammonia or CO2. Example: histidase. Isomerase, enzyme involved in the isomerization. Example: triphosphoisomerase. Ligase, enzyme catalyzing the synthesis reaction where the two molecules are joined and ATP is used. Example: glutamine synthetase. Specificity: the enzymes are highly specific and selective in their nature. Some of the properties are given here: stereospecific, reaction specific and substrate specific. For example, L-amino oxidase and D-amino oxidase always act on L and D amino acids. Reaction specific: when oxidase act on amino acid, it gives keto acid. When the same amino acid is attacked by the decarboxylase, it gives the amine. Substrate specific: enzymes are always substrate specific. For example, urease always act on urea and not other substrate. Mechanism of action of enzyme. The enzyme have the 3D polypeptide structure where there is a site called the active site. On the active site, substrate get bind and we get the enzyme substrate complex. The enzyme provide a surface to the substrate to undergo the reaction. After the reaction, the product is removed and we get enzyme for the further reaction. The effect of enzyme on activation energy. First of all, what is activation energy? Activation energy is the minimum energy required by the reactant to undergo the reaction. Here in the graph, we are seeing the two curves. The first curve is for the non-enzymatic reaction and the second curve is for the enzymatic reaction. Here we can see that the enzyme has lowered down the activation energy, and so the more number of molecules can undergo the reaction and we get the maximum product. Factor affecting biocatalyst. Concentration of biocatalyst: as concentration of biocatalyst increases, velocity of reaction increases. Concentration of reactant: as the concentration of reactant increases, the velocity of reaction increases. Temperature: with increase in temperature, the velocity of reaction increases up to certain point and then decline. pH: every enzyme have a particular pH to function. Concentration of product: as the concentration of product increases, the activity of enzyme decline because in the active site the product has been gone attached and there is no free site to substrate to attach to the enzyme. Light and radiation: when the enzyme are exposed to beta radiation, X-rays and UV rays, they become inactive. Activators: they are the metal positive ions such as Mn2 positive, Ca2 positive, etc. Advantages of biocatalyst: enzymes are a very efficient catalyst. As compared to the non-enzymatic reaction, the rate of enzymatic reaction is 10 raised to power 8 to 10 raised to power 10 high. Enzymes are environment friendly. Enzyme can catalyze a broad spectrum of reaction. Enzyme display selectivity. Disadvantages of biocatalyst: enzymes are provided by nature only in an enantiomic form. Enzymes require narrow operation parameters. If a reaction proceeds too slow under given parameter of temperature and pH, there is only a narrow operational window for alteration. High temperature and extreme pH leads to deactivation of an enzyme. Enzyme display the highest catalytic activity in water. Industrial application of biocatalyst. The largest scale industrial biotransformation is currently the conversion of glucose to fructose by the enzyme glucose isomerase, which account for production of approximately 10 million tons of high fructose syrup annually. The food industry also use the enzyme beta-galactoside for the conversion of lactose into glucose and galactose. In pharmaceutical industries, the biocatalytic process is used for conversion of fermentation product penicillin G into 6-penicillinic acid by an enzyme penicillase, which is used in the starting point for the production of chemically modified penicillin. There are some more applications of enzymes or biocatalysts in different fields, such as biotech and R&D, diagnostic, food and beverages, animal feed, pharmaceutical, biofuel, household, and etc. Thank you.